Universe and Earth's history. This timeline shows not only our history with life on Earth, but also the entire history of the universe. The scale on this timeline is such that 1 millimeter represents 2 million years, and 1 inch is approximately equivalent to 50 million years. Big Bang, the scientific theory of the origin, expansion, and development of the universe. Planck epoch, 10 to the minus 44 seconds. The fundamental forces in nature are unified, and the physical laws, as we know them, do not yet apply. Inflation, 10 to the minus 32 seconds. The universe is expanding exponentially, and the electroweak interaction separated from the strong forces. Quark epoch, 10 microseconds. Elementary particles, such as quarks and leptons, are formed. Hadron epoch, 1 second. The first nucleons, protons, and neutrons arise. Nucleosynthesis, 10 seconds to 20 minutes. Protons merge and primarily form helium nuclei through fusion. CMB, Cosmic Microwave Background. When the universe was 360,000 years old, light could travel freely in the universe. Today, we see this light as microwaves, and it has been named the cosmic microwave background radiation. The dark time. The universe expands and cools, causing electrons to be captured by protons and form atoms. The universe then becomes transparent. Despite this, there are still no stars or galaxies, so the universe remains dark without sources of light. The first stars. The universe's first stars consist almost entirely of hydrogen and helium. They are enormously large and have a relatively short lifespan. These stars are called population 3 stars, and exactly how and when they formed is still unknown. New telescopes like JWST will reveal more about the first stars that illuminated the universe. JWST. To learn more about the history of the universe, the James Webb Space Telescope, JWST, is used, among other things. By observing infrared light, the telescope can study the early stars and the light of galaxies that are otherwise beyond the visible part of the spectrum. The telescope's large mirror and advanced cooling system provide superior resolution and sensitivity, enabling detailed images and data to be obtained from distant objects. First galaxies. The first galaxies in the universe are formed through the accumulation of gas and dust in denser regions. Gravity pulls matter together and creates proto-galaxies. These galaxies grow and merge with each other, leading to the formation of the first galaxies. It is believed that galaxies were formed in large areas of dark matter. This unknown matter seems to be an important piece of the puzzle in understanding how and when the first galaxies took shape. Young galaxies. The young galaxies are small and produce stars at a furious pace, about 10 times faster than today. The galaxies in the early universe are much more chaotic when it comes to star formation. It is the stars in these galaxies that initiate the process of creating the elements and complexity that we see in the universe today. Large, massive black holes in the center of these galaxies play a significant role by influencing star formation. These active galactic nuclei are called quasars and emit a tremendous amount of energy and radiation. The Milky Way takes shape. Our galaxy, the Milky Way, is now starting to take shape as smaller galaxies merge and form the disk of stars that is approximately 100,000 light-years in diameter and 6,000 light-years thick. The galactic disk is surrounded by a large sphere of stars and gas, as well as dark matter. This unknown dark matter is believed to be a very important ingredient in galaxy formation. The The temperature is too high for ordinary matter, stars, gas, and dust, to gravitationally bind itself, so the dark matter provides an additional gravitational influence and holds the entire structure together. Galaxy collision. The latest major galaxy collision occurs when a smaller galaxy, dwarf galaxy, collides with our galaxy, the Milky Way. The dwarf galaxy quickly breaks apart, and its remnants are now scattered everywhere around us. It is common for galaxies to collide with each other, and when this happens, it is very rare for the stars to collide with each other. Rather, they tend to merge and blend together to form a larger galaxy. Half as big. No one knows exactly how large the entire universe is, but since there is a cosmic limit to how far we can see, we can calculate how large our visible universe is today and has been in the past. The diameter of our visible universe today is approximately 93 billion light-years. Approximately 7.8 billion years ago, the diameter of our visible universe was half the size it is today. Alpha Centauri forms. The star system. Alpha Centauri is a group of 3 stars that are gravitationally bound to each other. The system is the closest neighbor to our solar system, and recently we have discovered planets orbiting one of them. The names of the 3 stars are Rigil Kentaurus, Alpha Centauri A, Toliman, B, and Proxima Centauri, C. Proxima Centauri is currently located 4.2 light-years away from us, making it our closest neighbor. It is also around this star that we now know has at least 2 exoplanets. Alpha Centauri A and B are both approximately the same size as the Sun, and these 2 rotate around each other for about 80 years. Alpha Centauri can be found in the night sky of the southern hemisphere. The acceleration. When the universe was younger and also smaller, it was dominated by gravitational forces from matter. The universe did expand, but it slowed down. About 5 billion years ago, a turning point occurred, and the expansion began to accelerate, meaning it started to increase in speed. The cause is not fully understood, but it is believed to be due to a mysterious and invisible form of energy called dark energy. Dark energy has a repulsive gravitational effect, which drives the expansion of the universe. Although we do not fully understand what dark energy is, we know that its influence becomes more significant as the universe grows larger, and therefore, the expansion accelerates over time. Despite significant progress and new discoveries, many questions remain about this mysterious form of energy. The solar system is taking shape. Our solar system is formed in a massive cloud of gas and dust, called a nebula. Gravity pulls this cloud together, causing it to start rotating and compressing. In the center of this collapsing cloud, a dense protostar forms. When the temperature and pressure in the core increase enough, nuclear fusion begins, where hydrogen atoms fuse together to form helium. This process generates a tremendous amount of energy and gives rise to the young star, the Sun. As the Sun forms, it is surrounded by a rotating accretion disk consisting of gas and dust. Within the disk, small particles begin to collide and merge to form protoplanets. These protoplanets gradually grow through collisions and eventually form our solar system.